Energy is an important consideration in the self-sufficient design of a permaculture farm system. Energy can be sometimes hard to understand because it's always changing from different types, and the observance of it can be sometimes hard to see, such as the energy that's stored in physical things. It doesn't seem to do anything, but it's there stored in it. And what we try to do in a permaculture design is access the most suitable forms of energy for the type of work that we need to perform. So energy can be thought of as the ability to do work or the ability to do something. So depending on what we want to do, we can think about the available sources of energy in that environment that are most suitable for that particular type of work, and don't involve complicated transformations of energy into electricity, and then from electricity into other types, to do a type of work that can be accessed more directly using a different type of energy. So for example, if you want to pump water, instead of transforming a type of energy such as burning coal and heating water and driving a turbine to create electricity, and then using that electricity to pump the water, you could store the water high in the landscape and just use gravity to drive the water through the irrigation pipes to where you want it. This is a quick review of what energy is all about. So energy is in many different forms, and it's can never be created or destroyed, and it's always changing from one type to another. And the amount of energy that enters the system always equals the amount of energy that exits the system. But one of the things that's interesting is that some of the energy that leaves the system is always going to be heat. And that transformation of different types of energy into heat is called entropy. And that's a universal law of physics, that energy is always changing into less useful forms of energy. So heat is a less intense form of energy than solar radiation that's coming from the sun. And that transformation of energy over time into forms of energy less organized or less useful is called entropy. And it's one of the universal laws of the universe, is that over time the energy that's in the universe, as it's expanding and cooling down, is becoming less useful, and it's just dissipating out into space as heat. So when the energy is flowing through Earth from the sun, and it flows into different it transforms into different types of energy on Earth before it eventually radiates out into space as heat. It's available within biological systems and for us to do useful work. So biological systems organise this complex function to try to make the best use of that energy before it's lost as heat. And within our own mechanical devices and our own uses of energy, we try to make the most use of the energy we have available to us, and try to reduce the amount of energy that's lost as heat, unless we're trying to produce heat. To make the most efficient use of the energy, there's a couple of considerations that are good to guide your design considerations in permaculture. So the first one is just changes within your lifestyle. So what can you do in your current use of electricity or other types of energy and reduce that requirement? And a lot of that comes down to good design. So the water heater, for example, is the main use of energy, and by using a smaller water heater, by turning down the thermometer in it and insulating it really well, you can make a massive reduction in the amount of energy required to provide that hot water, or even provide that hot water through alternative means. So that's more the second point here, is looking at other ways to acquire the energy you need other than through electricity. So for hot water, for example, you could use a wet back to a stove, or you could use a solar water heater on your roof, or you can even run water through black alkathene pipe that is either on your roof that absorbs the heat from the sun on your roof, or you can even put it through a compost pile, and the heat from the compost pile can warm the water that's in that pipe. So, looking at different ways to either acquire the energy you need, and not through electricity, or by a reduction in the amount of energy required. The second biggest use of electricity generally in a house is the fridge, and again that comes down to efficient design. So instead of having a fridge hard up against the wall where the the extraction of heat is being trapped in a pocket and it's having to fight against itself to keep itself cool, you can ventilate the back of the fridge so that the hot air that it produces is being ventilated away from the fridge, and that will make the fridge work less hard to keep itself cool and make it work more efficiently. So you can do that by often just putting it into a cupboard and ventilating that cupboard from the outside, so the cupboard's insulated from the rest of the house, so you're not getting a draft problem. But the back of the cupboard can be ventilated to extract that heat that it produces, and that's going to make it work a lot more efficiently and require less electricity. And that cupboard can either be on the side of the house or it can be wherever that kitchen is and be ventilated from an outside air duct through the bottom of the house. And then the last point is the generation of electricity. So once you've become as efficient as you can with your use of electricity, once you've looked at different ways to acquire energy that don't require electricity, then you can look at ways to produce electricity on your site using the most efficient sources of energy available. So that might be water held up in a dam and running that through a little turbine perhaps to generate electricity. It could be water running through a stream and letting the water running through the stream to drive the turbine to produce electricity. Or it could be heating wood, and the heated wood can heat water, turn it to steam, and the rising steam can drive a turbine. Or even using solar electricity, so using solar panels up on your roof and generating electricity through a solar panel instead. All types of electricity are generated the same way, and it's within a turbine where there's a magnet that's spun within a coil of copper wire. And a magnet creates a magnetic force that electrons within the wire will interact with, and that interaction, once the magnet is spun, creates an electromagnetic force, and that will actually move the electrons within the wire. And what jet electricity is it's a flow of electrons through a conducting material such as a wire. So to make those electrons move, you need a force. So you need the electromagnetic force. And to do that, you need to be able to spin the magnet. So all methods to produce electricity involve some way to capture some form of energy to spin this propeller shaft to therefore spin the magnet within the coil of wire, and then the electrons, and then this wire will connect to a conducting wire where electricity will flow through that wire. So what we're really trying to do is find some way to spin a propeller shaft attached to this turbine. So you could do that by having this propeller shaft in a stream, and the flow of water over that propeller shaft will spin it. You can have it attached to a wind turbine and the flow of wind across it will spin it. Or you can have steam rising up past it, and that movement of steam across it will spin it. So if you're going to burn coal, wood, gas, oil, whatever it is, it involves heating up water and it will spin it that way. And you can actually get these turbines from the back of some of the old Fisher Paykel washing machines that you get in New Zealand. So you can, if you have a look at the back there, it's a kind of the reverse of this. So it puts electricity through this, and it will actually spin this, so electricity will actually spin this propeller which moves the washing machine, and you can run that whole system in reverse to generate electricity, as long as you can find some way to spin that propeller that's attached to that system. So you can whip out the turbine and then fashion some sort of propeller to the top of that shaft to capture some flow of energy across it and generate electricity. So it can be quite handy to be able to tinker with turbines and to be able to understand how electricity is generated, to have the capacity to develop and generate electricity on your site, depending on what sources of energy there are on a site that can be used to create electricity.